Good morning. Yes, good morning. Yeah. The last class we have seen about different types of sequences. Out of these, especially we have seen um, last two, like the third and fourth. Duplicates are allowed. Before going to see what we have completed, just what is this topic is about. We know what is meant by sequence, what is meant by set. Okay. Now how many types of sequences we could able to form from a set, this is the question. Okay, we can form sequences in four different ways. We can form sequences without considering order, like in any order, if you have abc, it is indifferent from ACB. Both will be considered as same. Okay, order does not matter, and duplicates are allowed in the first case. We can have AAC. Okay, this is allowed in the first case, whereas in the second case, duplicates are not allowed. So A, if we use once, we should not use A again in the same sequence. Okay, that is second one. Okay, next coming to third one, order matters. Like ABC is different from ACB. Okay, that is the second one. And duplicates allowed in the sense we can say ACA. Okay, this is allowed in third type of sequence which will form from a set ABC. Okay, next consider the fourth one, order matters and no duplicates are allowed. That means A if we use once in a sequence, we should not use A again. Okay, duplicates are not allowed, but order matters. So with respect to these four, we have seen first two. Okay, first two in the sense first we have seen like uh, duplicates are allowed. Okay, and order matters. Okay, that we have seen. If you have consider duplicates allowed in the sense, suppose we are having a set ABC, and we have to find out in how many ways we could able to uh, arrange these all. Okay, arrange these all with respect to this particular one. Duplicates are allowed and order does not matter. These three we have to arrange in the sense we'll be having three slots, and in these three slots, for the first slot we are having how many possibilities? Three possibilities. For the second slot also we are having three possibilities. For the third slot also we are having three possibilities. So it is nothing but 3 into 3 into 3. In that way we will be getting 3 power 3. Suppose if we are having the number of elements in the set as 4, then what will be the answer? Yeah, if we are having a b c d as allowed values, okay, allowed elements, then what will be the number of ways that we can or how many three letter words we could able to form by following this particular one. Like duplicates are allowed and the order matters. Yeah, what's the answer, ma? Yes, please respond, ma. 3 power 4. Any other answers? Actually, the question is four letters are there. We have to form, we have to count how many number of, yeah, 4p3. Again, one more time, you try to guess. Three letter words we have to form. Okay, so what will be the answer? For the first one, how many possibilities will be there? For the first one, yes, please respond by unmuting yourself. Please answer. For the first one, we'll be having four possibilities. Yes or no? Four alternatives. Next, for the second one. Yes, this is allowing
3, sir.
for the second one. Yes, this is allowing duplicates. So whatever the letter we have got here, that can be repeated second time as well. Yeah, how many possibilities? All these possibilities will be alive, right? So how many possibilities for the second one? Yes, try to
4,
answer.
sir.
Yeah, again 4 will be having. For the third one,
4.
4.
4, so it will be 4 power 3. Okay, this is with respect to this constraint. Duplicates are allowed and order matters. Then 4 power 3 number of possibilities, 4 power 3 number of words we could able to form from 4 letters with the 3 length words. Okay, this is a multiplication principle of counting. How we can able to count? Multiplication principle. Just how many possibilities we have for each placement, each vertical place, that we can count. 4 here, also 4 here, also 4. So 4 power 3 we have to multiply it. That's why it is called as multiplication principle of counting. Okay, this is with respect to duplicates are allowed. Let us assume duplicates are not allowed. That means again for the same question, what will happen? Here we will be having 4 alternatives for the
4.
first place. For the second one,
3.
3, 2.
third
2.
one will be having 2. So 4 into 3 into 2, this will be the answer. Okay, this we have generalized as n alternatives will be having for the first place, n minus 1 alternatives for the second place, n minus 2 for third place. This we could able to generalize it as NPR, isn't it? NPR. In that case, we'll be having 4p3 number of possibilities whenever duplicates are not allowed. Okay, only one time we could use any letter. Then out of 4 letters, okay, any 3 letters we can use. That too only one time. Each letter can be used only one time. Then we can have 4p3 number of possibilities. Understand what's the difference? If you understand this intuition, why we are having 4 types of sequences, then you will come to know what's when we have to use which one. Okay, don't be confused. Why? Because you might have learned these things earlier as well. Just try to get some clarity when we have to use which formula. That's it. Yeah, here first we have considered this one, this third case, that is order matters, of course, but duplicates are allowed. If duplicates are allowed, whatever the number of okay, how many possibilities we have for the first placement, same number of alternatives exist for other placements as well. So in our example, 4 possibilities for the first one, 4 for next one, 4 for the third one as well. So the number of ways will be 4 power 3. Whereas you consider this fourth alternative, that is order matters but no duplicates are allowed, then for the first one we'll be having 4, but for the second one we'll be having only 3. Why? Because we have used already one here, so we'll be remained with only 3. Next, we have used one here and one here, so we'll be having only 2 alternatives, so 2 here. So total number of possibilities will be 4 4 times 3 times, then 2 times. So this will be the value. This we can written as 4p 4p3. Understand the difference between third and fourth? Yes. Yes, if you understand this example, then formulas will be clear to you. You can generate on your own. Yeah. Next, let us if we have vertical number of tasks to be completed in sequence. Okay, sequence in this is order matters, right? So now order matters. First task can be completed in n1 ways. Okay, we are having n1 possibilities. For the second task we are having n2, like that. For the kth task we are having nk. So total number of possibilities will be multiplication of product of these always. So n1 multiplied by n2 multiplied by nk. This is the multiplication principle. This we have seen with respect to 2 tasks as well. T1, T2, n1, n2 number of ways will be there. Similarly, n1 to nk number of ways. Next, of course, coming to duplicates are not allowed in the sense we'll be having less number of possibilities for other cases. Like for the first one we may have n, for the second one we'll be having only n minus 1, for the third one we'll be having n minus 2, so on up to r elements we have to select, in the sense we'll be having n, then n minus 1, n minus 2, so on n minus r plus 1. It is nothing but n minus of r minus 1. So those many number of ways we'll be having. This can be written as npr, okay, according to the formula. This you can this we have seen in the previous class. Why it will come to npr. Yeah, is it clear? Any doubts so far? Yes, any doubts so far?
No, sir.
Okay, let us try to see some of the problems quickly. Like let us say we are having a word called logarithm. Okay, logarithm. From this word, whatever the letters we have, from these letters we have to count in how many ways, okay, or how many 3-letter words can be formed. This is the question. Yeah, how many 3-letter words can be formed? Yeah, how we can interpret this particular question? First of all, how many 3-letter words, in the sense how many letters we are having. Like from the set we have to form a sequence, right? Word in the sense sequence. From the set contains how many letters? What is the set?
9.
Yeah, how many?
9.
9, 8. How many letters? Just you count and tell. 9 letters or 8 letters?
9.
Okay, 9 letters. In logarithm, we are having 9 letters. Okay. Now, what is the question? 3-letter words we have to count. So, from 9, how many we have to select?
3.
3. So, what will be the answer? So,
9p3.
What? For the first one, how many possibilities will be there? For the first one?
9.
9. For the second one?
Sir, is it repetition allowed?
Try to from the question only you have to understand. That's what needed. If I tell the repetition is allowed or repetition is not allowed, then you are depending on my input, right? Try to interpret the question. From these letters, you have to form 3-letter words.
8, sir. Next.
Yeah. For the second one, 8. For the third one,
7.
7. So 9 multiplied by 8 multiplied by 7, it is nothing but NPR, isn't it? NPR. So what is N value?
9.
9. P, what is R? R is nothing but
3.
3. So 9P3 will be the answer. Okay. Next, let us assume, let us consider another word. Like we are having some duplicate letters in the word itself. We are having some duplicate letters. Like you consider leader. Okay, this is the word. Now you have to find how many 3-letter words can be formed. Yeah, how many 3-letter words can be formed? In general, what is the answer? 3-letter words in this, how many letters we are having?
6 letters.
Here 6 letters we are having. So in general, we will be having 3 starts. Yeah, because 3-letter words we are saying. For the first one, we will be having 6 alternatives. Second one, 5 alternatives. Third one, 4 alternatives. This is what we will be doing. So what is the answer? So 6 P3.
3.
But here, if you understand, if you consider, there exists a duplicate word, right? E appeared twice. So E appeared twice, in the sense whatever the combinations, whatever the words we have formed, those will be having some as common. Okay, same combination. Order matters, right? Here, words we are saying. So order matters. So whatever the words we will be forming, let us assume this one as E1, this one as E2. Try to understand. If you consider the second letter as E1, fifth letter as E2. So 6 distinct letters we are having. So from these 6 distinct letters, we will be selecting 3. So 6p3. Okay, 6p3, that is correct. But out of these 6p3, as E1 and E2 are same, E1 and E2 are same, those whatever the arrangements, whatever the words we have formed, those will be same. Yes or no? Try to understand the intuition. Then only you no need to remember the formula. Just by intuition, you could able to get. Yeah, try to understand. In general, if you assume these E's as second letter as E1, fifth letter as E2, then we will be having 6 letters. So out of these 6, we will be having 3 slots, so 6p3. That's fine. But whatever the 6p3 we have formed, those words, E1 and E2 are same. If you assume E1 and E2 as same, of course, in general also E1 and E2 are same, then whatever the words we have formed, those will be same, right? Some words will be common, right? Yes or no?
Yes, sir.
Yeah. So those we have to avoid. So how we can avoid is how many such words will be there that we have to find out, that we can avoid. So that we can do by dividing it with how many times it has repeated?
2
2.
times.
So 2 factorial ways those can be repeated. So 6p3 divided by 2 factorial ways, we can form 3-letter words. This is the answer. Got my point? Yes.
Yes, sir.
Any doubt? Yeah. Now I'll ask a question like, in how many ways? In how many ways? 6-letter words can be formed from these letters of the word leader. Question is, in how many ways we could able to form 6-letter words, not 3-letter words? What's the answer?
6 factorial by 2 factorial.
Yes, 6 factorial. Can we put it in the same format, like 3, which we have seen? Yeah. 6p3 by 2 factorial we have seen with respect to 3 length words. Suppose if you consider 6 length words, so 6p6 divided by 2 factorial. That's what the formula, right? 6p6. Now 6p6, what's the value? 6p6 is nothing but 6 factorial by 6 minus 6 factorial. 6 minus 6 is a 0 factorial, which is 1. So 6p6 is nothing but 6 factorial itself. Isn't it? So 6 factorial by 2 factorial. If you jump to that formula directly, 6 factorial by 2 factorial, you will not understand properly. If you put it in this format and try to get the value, then you will get confidence. Because both are similar questions. Or I'll tell the same question in other way, like in how many ways the letters of the word leader can be arranged? This is the question. In how many ways letters of the word called leader can be arranged? This is the question. So how many letters we are having? 6. These only we have to arrange. So how many slots will be having? 6 only. So 6-letter words, how many we could able to form from the letters of the word leader? This is the question. So 6p6, and we are having duplicate element. So we'll be dividing with 2 factorial. Let us assume we are having just lead. Then what's the answer? What will be the answer for the same question? Lead is the word. In how many ways we could able to arrange the letters of the word lead? Yeah, what's the answer?
4 factorial.
4 factorial. Yeah, 4 factorial. Why? Because we don't have any duplicate elements, so we no need to divide with any other number. This is the, I think you have got the clarity when we have to use which formula. Yes.
Yes, sir.
Yeah. Now these all things we have seen in the previous class. NTR is nothing but n factorial divided by n minus r factorial. Now if you need to distinguish from the first one and the second one, that is permutation and what is meant by set with repeated elements. What's the difference? Yeah, set with repeated elements means we will be using multiplication principle, isn't it? Multiplication principle will be having same number of alternatives for each and every placement, each and every place. But permutation in the sense order matters, and of course the vertical duplicates are not allowed. So we will be having uh, whatever the placement we are doing. Okay, we will be having different alternatives. Like for the first placement we will be having 9, for the second one 8, third one 7, like that we will be having for permutation. That's the difference between the set with repeated one and this one. And suppose if we have repeated elements, then we have divided like so. In fact, we have seen with respect to vertical leader example, 6 factorial divided by 2 factorial we have seen, right? In how many ways we can arrange a leader letters in the leader such that vertical, of course duplicates are allowed, all these things. Then 6 factorial divided by 2 factorial. In the same way, if you have more number of duplicate elements, then 6 factorial by 2 factorial. Suppose another letter also repeated twice, then 2 factorial. Suppose a letter is not at all repeated, then we can say 1 factorial. Generalized formula is like we are having n number of elements, and first element is repeated for k1 number of times, second distinct element repeated for k2 number of times, like that t distinct elements we are having. So tth element is repeated kt number of times. Then in how many ways we can arrange these is n factorial divided by k1 factorial into k2 factorial into kt factorial. Okay, if you add these all, we will be getting n. Okay, remember when we apply this formula and we wanted to check this one, k1 plus k2 plus so on kt is equal to n or not, we need to use we need to consider the elements which are repeated even single time as well. Okay, then only this particular one will be true, k1 plus k2 plus k3. Like you consider leader, how many letters are there? Leader, how many letters are there?
6.
6. Out of these, L is repeated how many times?
1.
1. So K1 value will be 1. Next, E is repeated how many times?
2.
2. So K2 will be 2. Next, A is repeated only once and D is repeated only once. E we have already considered. R is repeated only once. So K1 except K2, remaining all values will be 1. K1, K3, K4, K5 values will be 1. Okay, kt value is nothing but k5 value. Why? Because of 5 distinct words letters we are having, 5 distinct letters in this word we are having. So up to k5 only will be having. K1, k3, k4, k5 values will be 1. K2 value only 2. So if you apply in this formula, 6 factorial divided by k1 factorial, which is nothing but 1 factorial, then 2 factorial into 1 factorial, then 1 factorial, 1 factorial. Like this, we'll be having the formula. This is generalized formula with duplicate elements. Is that clear?
Sir, in the case of leader, we are adjusting the words letters in 6 ways, right?
6 letters. Yeah.
6 places, right?
6 places. Yeah.
Okay, sir.
Yeah. Within this word vertical, within this particular word, whatever the letters we are having, in how many ways we can arrange it? That's the question. Earlier we have seen, right? Same thing. So 6 placements we will be having. Suppose 3 letter words only means 6p3 divided by this. These are clear.
Yes, sir.
Yeah. These are several examples. Like we are having JEFF as the word. Here, how many letters we are having? Total 4. Out of this, first one that is J is repeated once, E is repeated only once, and F is repeated twice. So now, if you apply in this particular formula, we'll be getting this. Okay, the list is also given. Okay, next another example is how many distinguishable words can be formed from the letters? This one. Now M is repeated how many times? Only once. I is repeated 4 times. S is repeated 4 times. P is repeated 2 times, and the total number of letters are 11. So how many distinguishable words can be formed? N factorial divided by km factorial, ki factorial, ks factorial, kp factorial, which is nothing but this one, and the value is this one. Clear? Why we are dividing with km factorial, ki factorial, all these things is, as we have seen earlier, E1, E2, like this, I1, I2, I3, I4, like this we can distinguish. But whatever the words which can be formed with these letters, those will be indifferent from some of the other words. Why? Because I1 is equal to I2 is equal to I3 is equal to I4. All are I's only. So some words may be repeated. How we can avoid, how we can count only once is by dividing with how many number of ways we could able to arrange those internally. That is what the intuition. Clear?
Yes, sir.
Yeah. These are some of the other examples that you can try it out. I'll share the PPT. No need to worry. Yeah. So far what we have seen, the sequences that we can form with duplicates, without duplicates, but order matters. Whatever the order we have formed, that order matters. That is what we have seen. Suppose order does not matter to us. Okay, order does not matter. Then, like you consider, we are having the we are having 3 elements, 6, 5, 2. As of now, we have seen 652 is one possibility, 625 is another possibility, 256 is another possibility. Like this, we have considered whatever the combination we have formed. Okay, 652 is different from 625. 625 is different from 256. Like this, what are the all the possibilities we have counted? That is what we have done so far. That is, if we have 3 placements, okay, and 3 letters in the set like ABC, then we can consider ABC as one possibility, one way, and ACB, of course, although we are having same letters in this word and in this word, these two are indifferent. These two are different. That's why we have how many possibilities? 3P3, isn't it? 3P3, which is nothing but 3P3 is nothing but
3 factorial.
3 is nothing but 3 factorial. In 3 factorial ways, we could able to form 3 letter words with the letters ABC. Because 3P3 is the formula, isn't it? Yes?
Sir.
Yeah. Now, those 3 factorial is nothing but 6. So those 6 are like this. You can substitute in place of 652, you can substitute ABC, then we will be getting like ABC, ACB, like this 6 alternatives we will be getting. But whatever the 6 alternatives we have formed with the same 3 letters, those can be same if order does not matter. If order matters, these all are different. But if order does not matter, then if order does not matter, these all 6 can be considered as a single possibility. Yes or no? Why? Because all 6 are formed with
3
only
numbers.
those 3 letters. So all 6 can be considered as single letter. Understand?
Yes, sir.
Yeah. So if you consider like this, how many possibilities we will be having? Let us say we are having the same similar kind of word we'll be considering, like we are having pager. Okay, pager is the word. Now from this word, whatever the letters we are having, from this 3 letter words we have to get, but the order does not matter. Like AGE is one of the possibilities. Yes or no? AGE is one of the possibilities, and EGA it is another possibility. But here we will be considering this and this as same. Why? Because order does not matter. Now, how many possibilities we will be having. In order to answer this one, let us consider without considering by considering order, like AGE is different from EGA, then how many possibilities will be there? In how many ways we can form three letter words?
5p3.
Yeah, it is quite easy. 5p3 is the number of ways. But out of these, AGE, EGA, like this, these will be there. Okay, these are indifferent. We are saying these are same. So how we could able to consider, or how we could able to avoid those? Like these three letter words, how many we will be forming? Or yeah, how many we can form?
3 factorial.
Yeah, 3 factorial. Any three letters, if you select, those can be arranged within those itself. Yeah, 3 factorial number of ways. So we have to avoid those, right? As earlier we have considered n factorial divided by k1 factorial, k2 factorial, like that. If k1 number of times, if it is repeated, one letter is repeated, that we will be dividing. In the similar way, AGE is being repeated in other forms like EGA or GAE or in some other form. Okay, how many ways it is being repeated? Yeah, how many ways?
3 factorial ways.
3 factorial. Yeah, if you link this to this particular one, then it is very much easier to understand. Yeah, AGE is being repeated in other ways like EGA or GAE or GEA, like this. In other ways, 3 factorial number of ways it is being repeated, but as order does not matter, those all can be considered as same. As we have considered I1, I2, I3, I4, all will be arranging as like this. But at the end, I1, I2, I3, I4 are all are same. So we have divided that with 4 factorial. Similarly, how many letters we are having here for each set? 3 letters. So those 3 can be arranged in 3 factorial ways. So how many 3 letter words can be formed without considering the order is nothing but 5p3 divided by 3 factorial. Is it clear?
Sir,
Yeah. Now you consider what is the formula for 5p3? 5 factorial divided by
5 minus 3 factorial.
5 minus 3 factorial. Yeah, 5 minus 3. Let us write 5 minus 3 factorial. And this has to be divided by 3 factorial. Yes or no? This can be written as 5 factorial divided by 5 minus 3 factorial multiplied by 3 factorial. Isn't it? So 5 factorial divided by 5 minus 3 factorial multiplied by 3 factorial. Yes or no? Yes?
Yes, sir.
Yeah. Now if you observe, this is in the form of 5C3. Yeah, 5C3. So if you don't consider the order does not matter, then out of 5 elements, 3 elements have to be chosen, in the sense, then in 5C3 ways we could able to choose. Understand how we have got this formula from this 5p3 divided by this particular one, n factorial divided by how many number of possibilities we are like duplicates we are having, those we have to divide. So and what is 5p3, how we have got 5p3 also we have seen in previous class. Like 5 for first placement, for the second placement we will be having 4, for the third placement we will be having 3, like this. That can be written as 5p3. And by 3 factorial because of duplication, and order does not matter, because of that only we are considering AGE is a duplicate form of EGA. EGA is duplicate form of GAE, that is duplicate form of GEA. Like that we have seen 5C, we have obtained 5C3. Now 5C3 is the answer for which question? Now you tell, what's the question?
Major.
Yes,
Order
Major.
doesn't matter.
order does
Order
not
doesn't
matter
matter.
and duplicates not allowed. Duplicates not allowed, then only we will be getting 5p3. Yes or no? If duplicates are allowed, that is different story. Whenever you get P, automatically duplicates are not allowed. That you remember. Now, order does not matter, but duplicates are not allowed. That we have seen. Yeah, this is the these all are like we have what we have seen, that is only given here. Like we are having 10 elements. From this 3 we have to select. So how we can select 10p3? But out of those 3, if the order does not matter, then 3 factorial ways we can arrange. So 720 divided by 3 factorial, we will be getting 120 distinct possibilities, distinct sequences. Okay, this is nothing but 10c3. 10c3 value is 120. Yes or no? Yeah. Next, you can consider. Yeah, these all are same. Let us see this example. How many 5 card hands can be dealt from a deck of 52? Okay, order does not matter. 5 we have to pick. So direct formula is 52c5. So it will be the answer. Like this, 3 horses from 10 to place in any order. So this is nothing but NC3. Like this, direct substitution into the formula NCR if order does not matter. Okay, why if order does not matter? Now the question is whether if order matters will give bigger number, or if order does not matter will give bigger number. Which one will give larger number, ma?
If
If
order
order
matters.
matters.
Yeah. If order matters, then only it is like I can give you one famous example. Like um, suppose you went to some picnic kind of thing with 5 friends. With 5 friends, you want you have found out one what you call unique place like Taj Mahal, something like that. You are you consider just Charminar. Okay, you went to Charminar within Hyderabad. From Hyderabad place only, you went to Charminar. Now you wanted to take photograph. Okay, from out of these 5, one has to take photograph. Let us assume like this. Okay, don't say selfie is there. Don't consider odd examples. Now we are trying to build some possibility to link with this concept. One has to take photograph. So how many will be there remaining? 4. So 4 has to take can be in the photograph. Now in how many ways how many photographs you have to take in order to uh, in order to what you call satisfy that with everyone you have taken photograph? Yeah, what's the answer? Did you understand the example? Shall I repeat? 5 friends, you with 5 friends you went. 5 friends went to Charminar and you wanted to take photograph. Then one has to take photo. 4 can be in the one photo. 4 can be in one photo. And now, how many photos we have to take in order to uh, determine or in order to satisfy everyone that everyone has photo with all others? That is what the question. Yeah, only 5. Only 5 photos. If you take, that is sufficient. What's the formula? Yeah, 5 might be correct answer. How you have got 5? That you tell. 5c4. Yes, correct. 5c4. Why? Because we'll be, let us assume 1, 2, 3, 4 are the names. So 1, 2, 3, 4 are standing, are posing for the photo. Then 5 can take. Then 1 can come here, 5 can go here. Then 2, 3, 4, 5. Then 2 can come here, 1 can go again. Then 3, 4, 5, 1. Like that, we will be having 5 possibilities. That is 5c4. Okay, every time 4 can be in the photo. But suppose there exist three places, okay, three places, but it is like one has to be in the right side of one friend, like one, you consider 1 2 3 4, two, for two, one is in right side, three is in left side. But I wanted to have a photograph with three in right side, one in left side. That is also matter to me. Understand? Then how many possibilities, how many photos I have to take? What's the answer? Did you get the question? Yeah, 5p4. Definitely 5p4. Why? Because order matters. So 5p4. What's the answer? 5p4. 5 factorial divided by 5 minus 4 factorial, which is nothing but 5 factorial itself. So how many photos I have to take? 120 photos, isn't it? Yes. Yes. Did you understand, ma'am? Please respond orally, ma'am.
Yes, sir.
Yeah. So now 120 photos we have to take. Whereas if a placement does not matter, just having that particular person in frame is sufficient, then we can say only 5 photos are enough. Otherwise, we have to take 120 photos. This example is quite easy to remember when to use which formula. Clear? Next, let us see other possibilities. This is very, very important concept actually. Let us assume, don't read this slide. I will tell you the example, then you try to understand. Let us assume there is um, there is ice cream parlor. Okay, there is an ice cream parlor. Okay, and that vendor, ice cream vendor, has to sell 10 ice creams. Okay, has to sell 10 ice creams to whom is there exist let us assume three three friends went to ice cream parlor, and 10 ice creams have to sell to these three people. This is what you call the context. Now, or you consider in other way, like instead of three friends, um, three flavors you consider. Okay, 10 what you call there, 10 ice creams he has to sell. Okay, he is having so many variety, what you call ice creams, okay, which can be classified into three different categories, like vanilla, strawberry, like this we are having some three varieties. Now from these three he has to sell how many? 10. Then how he has to divide these 10 among these three? This is the question. Try to understand the context. We are having three varieties of ice creams. Okay, we have to sell 10 ice creams. Okay, then in how many ways he could able to, how many ways he could able to distribute, or he could able to sell out of these three varieties? Like he can sell only first variety 10, next variety 0, next variety 0. Other possibility can be, yeah, can you tell? Other possibility will be like 5 4 1. Yes or no? Yes, are you able to follow?
Yes, sir.
Yeah. Next 2 2, what will be the next one? 6. Like this 5 2 5 2 3. Like this we are having several possibilities. Now how we could able to what you call determine in how many ways he could able to sell? This is the question. Yeah, 10p3 in general will be tempting towards either 10p3 or 10c3, whether it is repeated or not repeated, like that we will be saying. But But here we need to analyze in other way. Can you give an example, what you call justification, why it is 10p3? Why it is 10p3 or 10c3, whatever the answer may be yours. Yeah, what's the justification if it is 10p3? If it is,
Sir, I think the order doesn't matter here, sir.
yeah, order does not matter. So can we go for p? If order matters, then only we'll go for 10p3, right? Or p, right, in general.
Yes, sir.
Yeah, so obviously it is not p. Why?
Yes,
Because
sir.
order does not matter. So we will be having what you call less number of possibilities. Yeah. Coming to duplicates allowed here. It is indifferent from it is different from earlier one. Like earlier, if you have ABC or ABCD, out of these, we have to select or we have to form three letter words. Okay, three letter words. What's the formula? Order does not matter. So what's the formula?
4C3.
4c3, definitely. Yeah. But here duplicates are allowed. Duplicates are allowed in the sense, like duplicates are allowed in the sense here I can select all 10 varieties as all 10 ice creams as one variety. From this only I can select all 10. Or from here I can select 5, next 4, next 1. Or from first one I can select 2, next 2, next 6. Or first 5, then 2, then 3. Like this I can select duplicate items. Yes or no? So duplicates are allowed. Then how we can solve this? Try to understand the question. I am not concentrating on the. I'm not, why I'm not going directly to the solution is you need to accustom to the question. Then only answer will come intuitively. Yeah, yeah. What's the how we can approach this? How we can distinguish from the previous question is duplicates are allowed here. Order does not matter, but duplicates are allowed. Yeah. Now how we can consider this one is like this can be interpreted as like this. Let us assume we are having we are having 10 ice creams. Okay, 10 ice creams like this. Okay, are of different types. Okay, there can be what you call now we wanted to what you call divide these 10 into how many groups? Yeah, 10 into how many groups? You please tell.
3 groups.
Three groups. So let us assume there exists one how many separators we require is at least no, sorry, exactly two separators we need. Like here, let us assume we are having a separator and another separator is here. Now if you have let us assume we are having one bunch, we wanted to divide into two groups, then how many separators we require? One
1.
separator we require. Similarly, if you wanted to divide into three groups, then two separators we require. Similarly, if you wanted to divide into r groups, then how many separators we require?
R minus 1.
Yeah, r minus 1 separators we require. Like this we can analyze. Now, where we have to put these separators? This is the question actually. Where we have to put these separators? Like first we can select three. Like first type ice creams we can select three. Next two. Next five. This is one possibility. Like if you drag this to left side, then it will be down. Then it will go up. Yes or no? Like 2, 3, 5. If you drag to the right, then it may go to 4, it may go to 1. Like this where we have to place this particular separator. Try to understand the point. Where we have to place this where we have to place this separator. How many separators we have?
2.
2. Now you consider these separators also, as ice creams. I'm repeating once again. These separators are also as ice creams. Now, total how many ice creams we have to place? Yeah, total how many ice creams we have to place, including separators, I am saying.
12.
12. It is
12.
nothing but 10 plus 10 plus
2.
2. What is this 2? What is this 2?
Separators.
Separators.
Separators. How we have got 2 separators only? Why? Because into 3 groups we have to divide. Yes or no? That's why we have got 2. So it is nothing but 3 minus 1. Yes or no? 10 plus 3 minus 1. So total how many we have got now? 12. So out of these 12, okay, out of these 12 slots, how many separators we have to place? Especially if you place the separators, that is sufficient to climb what you call, how many vanilla, how many strawberry, how many chocobar, isn't it? If you place the separators, that is sufficient. Before that, how many we will be having? Those many vanilla. Next, from first to second, how many we have? Those many strawberry. Remaining will be chocobar. Now you say from these 12, how many we have to select? Yes. From these 12, how many we have to select? How many we have to place exactly?
10.
Just yeah, 2 separators. If you
2.
if you place, that is sufficient. So in how many ways we can select? In how many ways we can select? 12 slots we have got. Out of these, 2 we have to select. So how many ways?
12C2.
Yes, 12C2. Yeah, 12C2. Why? Because duplicates are order does not matter. Yeah, 12C2. So now this can be written as this 12. How we have got? 10 plus 3 minus 1. This we have seen already. 10 plus 3 minus 1. What is this 2? 2 is nothing but 3 minus 1, right? Yeah, number of separators, that is nothing but 3 minus 1. Now, if you consider n elements, okay, total n items we are having, we have to divide into r groups. N items we have to divide into r groups such that then how many ways? N plus, yeah, please tell. How many separators? R groups in the sense?
NCR minus 1.
Yeah, n plus r minus 1. C r minus 1. N plus r minus 1. C r minus 1. Yes or no? This is what we have got. Yes? Is this clear?
Sir, but in some cases, we don't use any separators now, sir. If we take 10 as one flavor, then we don't have any separator.
Yeah, 10 as one flavor means then we know it to 10 as one flavor in the sense. Then we will be we have to put these 2 separators here. Total 12 slots we will be having, right? 1 to 12. Then we will be putting these 2 separators at 11 and 12. So before this we will be having one flavor. This entire thing has one flavor. After that we are having 0 0. Understand?
Yes, sir.
Then also we have to place separators. Then only we'll come to know 10 0 0 as one possibility. Got it?
Yes, sir.
Even you can consider 2 separators at first itself. So 0 0 10. That is the possibility. Got it?
Yes, sir.
Yeah. So coming generalize it now. With respect to other example, it is explained in these slides that you can go through with some other example. This is the placement. Yeah, this you can consider as the what? Separator. Into 4 we have grouped. So how many separators we have got? Into 4 groups we have divided. So how many
3.
separators? 3 separators. Yeah. So what will be the number of possibilities? Total, if you consider 2 plus 3 plus, yeah, total 10 we have got. So 10 plus 10 plus
3.
10 plus 3, which is nothing but 4 minus 1. C
3.
3. Yeah, this is the answer. Like, I think it's Not exactly this one. This is some other question, or they have given wrong here. Okay, I will correct it and upload. Don't worry. Yeah, this is the formula. Now we are having order does not matter and duplicates are allowed for a selection of r items from a set of n items. Then the formula is n plus r minus 1 c r minus 1. This r minus 1 we are selecting for separators, that you keep in mind. That's why we are having r minus 1. Although we are selecting r items, what's the formula? N plus r minus 1 c r minus 1. Understand? Yes. Yeah. One. Okay. In the next class, we will see some examples related to this initially. Yeah. Thank you, ma. You can enter your roll number and can leave. Thank you. If you have any doubt, you can ask.